Okay, so we talked last time about solving one-step, two-step equations. As I understand it, these are things that you should have seen towards the end of pre-algebra or 8th grade math or whatever it was that you took. So hopefully that was some nice review. Now we're going to get into some multi-step equations. What do we do when we have a variable on both sides of the equal sign, right? And then there is the possibility that in order to find the value for a variable, it could be anything, right? It could be any real number, which we'll talk about being infinitely many solutions. Or it could be a situation where there's absolutely no solution whatsoever, okay? So what we're trying to do through this process is to find the solution for this equation. And again, we're using the idea of equivalent equations, which all have the same solution to get us there. Okay? So by the time we're finished here, you should be able to solve multi-step equations. We need to be able to solve equations with variables on both sides, and then identify equations that are either identities or have no solution. Okay? All right. So we get started. Again, we did this last time, and we're going to do it again now, and we're going to keep doing it because we want to make sure that we can simplify and simplify properly. If we can't simplify properly, then solving these multi-step equations becomes very, very difficult, right? And so some quick practice on simplifying. Go ahead and take a couple seconds, knock those out real quick, make sure that we're good to go. And we'll move on into our equations. Okay? First one, right? All we got to do is combine like terms, right? Your 2x and negative 5x are your like terms, 3 and 7 are your like terms. And then in the second one, the trick is you got to distribute first and then combine like terms. What you should come up with is something like this, right? So the first one, you should get negative 3x plus 10. And we just combine like terms. And then the second one, we got to distribute that 3 first, negative 18c plus 27. And then we add the 5c, combine like terms, and you should get negative 13c plus 27. Okay? Anybody not get there and not understand why? If you can't do this, you can't solve equations. Okay? And then the third one, same thing, right? We got to distribute that negative. When you distribute the negative, all you're doing is changing signs inside the parentheses. So you get 6b minus 3b minus 8. Combine like terms, and you get 3b minus 8. Okay? Again, anybody have any questions about those three? Okay. Then what we want to do is we want to add this into our list of things we need to do. We want to solve an equation, right? Like this guy. If we're asked to solve, okay, we know at this point that solve means isolate the variable, right? Get it on one side of the equation all by itself with the coefficient of 1, okay? But in this particular equation, we've got two m's. We've got two terms that have the variable m in it. So which one are we supposed to get by itself, right? And that doesn't make a lot of sense to talk about. So what we know we can do is using the idea of equivalent equations still, right? And so if I came over here and asked you this, we'll do equivalent expressions first. Are those two expressions the same thing? Are 5m plus 2m and 7m the same thing? Yeah, they mean the exact same thing. They look different, but they mean the same thing, right? You get the same answer if you plug in 2 for m, right? So what we want to do is apply that useful piece of information to help making our equations look a little bit easier to solve, right? So I can use that idea to go ahead and combine like terms. Oh, what happened? Okay, to combine like terms. We can combine those guys, right? Now, if they're on the same side of the equal sign, then we're just simplifying and we're just combining like terms. Oop. And so the idea is to make sure that we have an equivalent equation. Okay? We'll deal with any issues as far as that goes when they come up. But that's it. And now you're in your two-step equation situation, right? Here we know that we have to undo the subtraction first by using the addition property. And then we got to undo that multiplication by using the division property. So that m is 4. Okay? So we just want to make sure that we can simplify on either side of the equation. All the way down, combine like terms, distribute if we need to, and then we can go worry about trying to isolate that variable. Okay? All right. Now, how we want to do this, right? 11m minus 8 minus 6m equals 22. First thing we want to do, yeah, combine those like terms, right? Simplify each side first. Treat each side differently, right? Or separately and simplify them. 11m minus 6m.
5.
Yep. Now you're in your two-step equation situation. You got to undo your subtraction or addition first. Then undo your multiplication. Okay? So m is 6. All right?
I'm ready.
Questions, issues, concerns? First thing you want to do in this guy is do what?
I don't know. Combine.
Yep, combine your k's. Combine your like terms here and here. So negative 30, we combine those two and we get? Yeah, negative 7k. Now we're in our two-step equation situation. We don't have any, we can't simplify anymore. So we undo that positive 4 by subtraction. Get negative 34. This is negative 7k. Make sure that you bring that down as a negative.
Oh my gosh.
Okay.
You did? No.
Okay. Bring down your subtraction sign as a negative. Make sure you do that.
Oh my gosh.
Okay.
I'm so bad.
Questions, issues, concerns? What?
The next one's already solved.
Next one. Show you a little bit different type of problem. Okay. All right. So simplifying each side of the equation might sometimes also include a situation where you have a set of parentheses, and we want to make sure that we still do our simplifying here. We still want to make sure that we distribute that 3. At which point we're still going to look to combine like terms if we can. Sometimes we'll be able to, sometimes we won't. Okay? And then we can start trying to isolate our variable by adding 18 here and here. Then divide by 6, and x ends up being 6. Okay? Oh, by the way, while we're talking about it, while we're solving these equations, what are we doing again? Okay? Oh, that's not what I mean. What are we doing in the equation? We're trying to find the solution, right? What's the solution? The solution is the value of the variable, right? This equation down here is equivalent to this guy right here, which is equivalent to this guy right here, which is equivalent to this guy right here. We're using equivalent equations to find out what the value of x is. Now that we know that, or we think we know that x is 6, the wonderful thing about math is you can check it, right? You can check it. Go take your value for x and put it back up into the first equation, the first equivalent equation, and make sure they are equivalent, right? If I do that, 18 equals 3 times 2 times 6 minus 6. If I do this real quick, 2 times 6 in here is 12. inside parentheses again, order of operations, 12 minus 6 is 6. 3 times 6 is 18. Does 18 equal 18? Yes, then we know we're right. You should never hand me a test or a quiz that doesn't have all the right answers on it, because you can go check it. Okay, so make sure that you're checking your work. All right? All right. Is what? Yeah. Distribute the negative 8. Negative 16x. Negative 8 times negative 1 is positive 8. Okay? And then we want to undo addition and subtraction. First, trying to isolate that variable. Okay? And then leave it as a fraction and just reduce. Should be negative 7 over 4. Okay? All right? Good? Make sure that we're all on the same page. First thing you do here. Distribute that 5, right? So 15p minus 10. Then we got to add 10. Then divide by 15. Okay? And again, you should be able to plug that 2 back up into the p in your original equivalent equation and do the arithmetic and get an equation that makes sense, right? If 2 is going to be the solution. All right? All right. Next thing I want to talk to you about. Okay, this is all about sort of handling different situations at this point. Okay? If we get something like this, 3/4 x minus 1/3 x equals 10. Okay? Guys don't like fractions. You're constantly wanting to divide them out and get decimals. Okay? All right? Fractions are your friend. You have to get used to liking fractions. But for those of you that don't like fractions, there's a way to get an equivalent equation to this guy that does not have any fractions in it. Okay? So if you don't like fractions, you're going to definitely want to pay attention to this. What we can do. Now, if I wanted to simplify that, if I wanted to combine like terms, what would I have to do first? If I wanted to combine 3/4 x minus 1/3 x, what would I have to do first?
Common denominator?
Right. You'd have to get a common denominator. You'd be looking for that least common multiple. Okay? What is that least common multiple in those fractions, in all of your fractions? 12. 12 is your least common multiple between 4 and 3, and oh, by the way, there is a denominator for this 10, okay? Just so we're clear about that, okay? But we'd have to use 12. We'd have to get a common denominator of 12. Well, if we were to do that, we would, of course, like in our warm-up, right? We would multiply the first fraction by 3 in the numerator and denominator to make sure we got 12 in the denominator. Multiply the second fraction by 4, okay? But I propose to do something a little bit differently. If we take that least common multiple of 12 and we simply multiply everything through, okay? Everything, every term. Multiply every term by 12. Something very magical happens. Okay? Now, before we do that, hopefully the first question in mind is that allowed? I mean, are we going to get an equivalent equation if we multiply all the terms by 12? The answer to that is yes. And I offer up this as proof. If I were to solve that equation up there in the top right-hand corner, 2x minus 2 equals 4, you'd get
1.
No, try again.
-1.
No, try again.
4 minus 2.
So you're going to add the 2 to get 6. You get 3, right? Now,
Add the 2.
what if I multiplied every term by 2? You get 4x minus 4 equals 8. If we solve that, is this guy an equivalent equation to the first guy, where the first guy's solution was 3? When you add 4, you get 12. Divide by 4, you'd get 3. So yes, if we multiply every term through by the same number, then you're still going to get an equivalent equation. Watch what happens when we do this. If I multiply 3/4 by 12, we can cross simplify, right? 4 goes into 4 once. 4 goes into 12 3 times. For this guy right here, I can multiply numerator times numerator. 3 times 3 is 9. Denominator by denominator, 1 times 1 is, then 9 divided by 1 is, and so you just get 9x. Same thing here. 3 goes into 3 once. 3 goes into 12 4 times. Numerator times numerator gets you 4 times 1, which is 4. Denominator times denominator gets you 1 times 1, which is 1. That's still just going to be 4 over 1, or 4, so we get minus 4x. Now, no denominator, or not, there's a denominator of 1 for that 10, but we can't cross simplify. So we're left with just 10 times 12, which is 120. It's an equivalent equation with no fractions anymore. Okay? So instead of converting your fractions into common denominators and combining them, we take that least common multiple and we multiply every term by it. And that's what happens. Okay? Does that make sense? And then we continue to solve. 9x minus 4x is 5x. Divide by 5, and you get 24. Okay? Make sense? We're going to give that a shot. Okay? So,
We have a negative sign of ours.
now it's a fraction bar. Okay? Now, the least common multiple for your denominators. The least common multiples for your denominators is what? Yeah, it's 5. They're already there. Okay? Multiply by 5 here. Multiply by 5 here. And multiply by 5 here. Okay? 5 times 5 is 25, so we get 25y here. If you cross simplify, 5 goes into 5 once, 5 goes into 5 once. 3 times 1 is 3. 1 times 1 is 1. You get 3 over 1, or just 3. And same thing over here. 5 goes into 5 once. 5 goes into 5 once. 4 times 1 is just 4. Okay? That is? Okay.
I thought that was a negative sign.
Hold on. Hold on. Let's go through and do this two-stepper here. We're going to add 3, add 3. And then divide by 25, divide by 25. Okay? And there we go. 7 over 25. Now, sure we're doing least common multiple for your denominators, or what? What's your least common multiple? 8. Multiply by 8. Multiply by 8. Multiply by 8. Okay? I'll offer up an alternate way of looking at this that I think Rex just did. Okay? 2 times 8 is 16. If you don't want to cross simplify, you don't have to. Now, if the numbers start getting a little bit bigger, then it can get a little bit more complicated. But you could always just do 8 times 3, since they're both in the numerator, and get 24. And then divide by 4 and get 6. Might be a little bit easier way to approach this as well. Okay? And the other guy, 5 times 8 is 40. Divided by 8 is 5. Okay? An alternate way to look at this if you want it. Okay? So now we're going to add 5, add 5. Then divide by 6, And so K equals
Two.
7 over 2.
I didn't get to 2 points. What did you get to?
Okay. Well, if you're going to divide, you're going to reduce 21 over 6. You're going to divide them by 3, right? Okay. Questions there?
Oh, we were wrong.
Okay. Here we go. Make sure we're all on the same page. Your least common multiple here. 6. Yes. So multiply through by 6. Right? I don't know. Do you like the last way a little bit better? 6 times 1 is 6. Divided by 6 is 1. 6 times 2 is 12. 12 divided by 3 is 4. And then 2 times 6 is 12. Okay. And then divide by 4, divided by 4. And y is negative 11 over
I got the answer.
4. Good. Good. Ultimately, that's all that really matters. Okay? All right. Story problem. Story problem. Martha takes her niece and nephew to a concert. She buys T-shirts and bumper stickers for them. No.
Okay.
The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? And so there are ways to have different situations modeled by an equation that's a little bit more complicated than our 1 and 2 step equations that we've been doing before. Okay? So, from a story problem, very good strategy here. First thing is to define any variables. What do we not know in this story problem? Right. So go define a variable. Right? Choose a variable. Anything. What do you guys want to use?
D.
Um, okay. X works for me.
That looks like a fish.
Okay. X. X is going to stand for,
Cost of 1 shirt.
right, cost of a shirt. Okay. Now, we got to come up with your equation. If Martha's total is $67, that means by the time we're finished combining everything that she is buying, that total is going to be $67. So that should be what your equation is equal to, right? Now, where does the $67 come from? Right. So how many bumper stickers did she buy? 4. How much were each bumper sticker?
1.
So to find out how much of the $67 were bumper stickers, we got to take 4 times 1, right? But we're not finished. We have to add in the shirts. How many shirts did she buy?
2.
I think she bought 3.
She bought 3. No, she bought 2 shirts.
And then, no, her niece wants 1 shirt, her nephew wants 2.
Oh.
Okay? Now, how much does each shirt cost? We don't know, so let it be X, so it's going to be 3 times X, right? And so there's your equation to model this situation. And we go to simplify. 4 times 1 is 4. Right? Subtract 4. We get 3x equals 64. Divide by 3, divide by 3. Wait, the 63. Sorry. So x is 21. So the cost of a shirt is $21. Okay?
It was what? $21?
Yeah. All right. Any major issues, questions there? Okay. Then let's keep progressing here. What do we do if we have a variable on either side of the equation? Right? Remember the whole point in isolating, when we solve an equation, we're trying to isolate the variable. The way we isolate the variable is to have it all by itself on one side of the equation with a coefficient of 1. Okay? Well, if we start off with our variables being on, or two variables being on opposite sides of the equal sign, and we've got to get them onto one side. Okay? I don't want a variable on both sides of the equal sign. So I need to find a way to add out one of them to 0. Okay? I got to find a way to add out one of those variables to 0. Now, does it matter which one? Ultimately, it doesn't matter. But if you can condition yourself to try to figure out a way to keep your coefficient positive, then you're going to be in good shape, right? Now, I look at this, and I want to find a way to add out that 2x to 0. So what do I have to add to 2x to get 0? What do you add to 2x to get 0? Yeah. Yeah, so we're going to basically subtract 2x. Now again, the idea of equivalent equations says that if you're going to do this to the right-hand side of the equation, you have to do it to the left-hand side as well. Okay? So that's going to be 0. 5x and negative 2x is 3x. And now we're in our two-step equation situation where we subtract 2. And so x is 4. Okay? All right? Any major issues or questions there? I want to tell you. Okay? We still want to make sure that we try to simplify either side of the equal sign. Okay? And then isolate your variable. All right? All right. Still the same deal. We still want to make sure that we're simplifying all that we can first and then trying to isolate our variable. And most of you guys are already there. So you distribute the 2 and the 3. Okay? And I knew this was going to happen. You have to be careful. There's a difference between the variables being on the same side of the equal sign versus on opposite sides of the equal sign. If they're on opposite sides of the equal sign, you can't just combine them. If they're on the same side, you can just combine them because we're just simplifying, okay? So be careful about that. Here, I need the 3x I need to get rid of on the right-hand side, so I'm going to make sure it adds to 0 by adding it to negative 3x. And I got to do the same thing on both sides. I'm going to add 2. And so 7x is equal to 35. Divide both sides by 7, and x should be 5. Okay? Good. Everybody good? All right? 17. Try 17 real quick. Okay? Here we go. Nothing to do on either side. We can't simplify the left side or the right side. No distributing, no combining like terms. Okay? But I'm going to add 2y. Guys. 3y, 2y is 5y. Add 2 to both sides, because now we're in our two-step situation. Okay? So y ends up being 2, right? Everybody there? Good. Write these values in. We won't necessarily stop and work these, but write these values in. There's 18. So I do want to make sure we get to everything. Okay, and even give you a couple seconds of a head start. Okay, well there you go, you see it. as I was working it out. Distribute the 7 and the 3. Okay? 28 minus 7a equals 3a minus 12. Again, it doesn't matter. I went ahead and added the 7a to both sides. That kind of helped me keep my variable's coefficient positive. Okay? It's just, I don't know, it doesn't really matter. But then you add 12 to both sides, divide by 10, and a should be 4. You should get 4 there. Okay? If you haven't finished it, write the answer down and try to get to it in just a second. All right. Well, hold on. Nope. No, yes, you do, but don't. We're not there yet.
Finish our notes, then we don't. We only have 6 minutes.
Yep. Okay. Okay. All right, number 19. The printing place will print business cards for 10 cents each plus a setup charge of $15. The card creator offers business cards for 15 cents each, which is more, but the setup charge is less. What number of business cards costs the same from either printer? So at what point is the cost from the printing place going to be the same as the cost for the card creator? That's useful information because you need to order more or less than those number of business cards. That will tell you where you need to go, right? Now, how do we figure that out? Well, we can write an equation to help us out, right? So first of all, you see there some numbers are circled, right? There's 10 cents each from the printing place with the setup charge of $15. 15 cents each from the card creator with a setup charge of $10. What number of business cards? That's what we don't know, right? So let that be C for number of cards. Now, model each company's cost, right? 10 cents each. Each is your clue that you should be multiplying the 10 cents times something, right? And what we should be multiplying it by is the number of cards, which is what we don't know. So 10 cents C will tell you how much the cards are going to cost, but then the printing place is going to add in a $15 setup charge. Now, for the card creator, it's 15 cents each for the cards, but then a setup charge of $10. Now, the last thing that we need to pay a lot of attention to is the question is what number of business cards cost the same? Which means that we want to know when the printing place and the card creator are right, equal. If they're the same, they're going to be equal. So we're just going to set these two guys equal to each other. And here's a situation where you can get an equation that's modeled. Okay? Now, we want to go through and solve this guy, right? Again, we want to make sure that our variables are on one side of the equation. So we're going to subtract 10 cents C here. And over here, which leaves you with 5 cents C plus 10. Now we're going to subtract 10 here, subtract 10 here. Okay, and then you divide by, well, that's 0.05, but you see it there. Much better writing than mine is, okay? And so C gets you, 100. So it takes 100 cards for them to be the same. If you need fewer cards, you're going to use one company. If you need more cards, you're going to use the other. All right? There's another story problem there. I'm going to let you guys try to set up, and you can go check your setup through the notes later. Okay? Let's do one more together. Watch this. If we go to solve this equation right here. I happen to mention you guys are going to take a quiz over this stuff the next class period. So then you might want to set up and pay a little bit of attention to what's going on. Okay? First thing you want to do. Is distribute that too, right?
Yep.
Now, our variables need to be on one side of the equation. So, Subtract 10x from both sides.
You get 0x.
Right. 0 there. It's enough, Jaden. And we get 0 there. So you get 12 equals 12.
Isn't that like,
Does 12 equal 12?
yeah, isn't it like?
Will it always equal 12?
Yes.
Is there any value of x where if I plug it in, 12 will not equal 12? No. That means that x can have any value. And this is where you have infinitely many solutions. Okay? Okay, let's take a look at the next one. Right, so 9m minus 4 equals negative 3m plus 5 plus 12m. Okay, see what happens when we try to solve this guy. Well, first we're going to combine these like terms, right? We want to simplify each side of the equal sign. Negative 3m and 12m get you 9m. Right? And then we're going to, I don't know, call it collecting your variables on one side. Right, but we need to get it to where the variable is on only one side and not two. So I'm going to add this variable out to 0 by subtracting 9. So I get 0 over here. 0 plus 5 is 5. And I get 0 over here. And 0 minus 4 is negative 4. And take a look at that. Now the last one, 12 equaled 12. And you guys said that 12 always equals 12, and that's true. Now we've got a situation where this equivalent equation is trying to tell us that negative 4 equals 5. So does negative 4 equal 5? And the answer to that question is no. Will negative 4 ever equal 5? No. Can I put, so what does that mean as far as a solution to this? Well, I can put any value I want to in for m, and I'm still going to get an incorrect equation of negative 4 equals 5. Since they don't equal each other, this is a situation where there's no solution. There's no value for m in which I can substitute in for m and make this equation make sense to be a solution. So the difference between this guy and the last guy. The last guy, I could put any value in for m that I wanted to, and it was always going to be a true equation. I was always going to get a solution. Here, we can't. Okay? So a little bit of a difference there. All right? 23. I'll give you a couple of seconds to get started on that. Give that a shot and see what you come up with. Okay, if you're still working, you can pause the video, but I'm going to go ahead and move on. Okay, so simplify. We want to distribute this negative 1 first. Well, we didn't really want that. I like walking you guys through this. We're going to distribute the negative 1 first. And so we get 2x plus 7 equals negative 3 plus 2x. Okay? Now, we need to, again, subtract out one of the x's on one of the sides of the equation. Right? Again, that's 0. And so we get 7 equals negative 3. Does 7 equal negative 3? No, it never does. And so we're in a situation where there is no solution for that particular equation. Okay? Good. And so you see it there. Another practice example here. Okay? Again, you can pause the video for a second, work the problem, and then come back and check to make sure that you're doing it right. And here's what you're going to want to do. Right? So distribute this 3. So you get 12b in minus 6. And then you've got this guy here. And another way to look at this is that 12b minus 6 and negative 6 plus 12b are really the same thing, right? You can always flip-flop the order of the right-hand side so the 12b comes first and the negative 6 is behind. You get 12b minus 6. Since the sides are the same, that means that if I subtracted 12b from both sides, I'm going to get negative 6 equals negative 6. Another way to look at this is if your left-hand side and your right-hand side are exactly the same, then we're going to be in a situation where we have infinitely many solutions. Okay? And so we can write that out and move on. Okay? Algebraic proof. Now what I want to do is I want to back up and show you the story problem that we didn't get to. Okay? So let's work this guy out. Sally just opened a new pizza shop. She spent $600 on equipment to get the business started. She sells pizzas for $12 each. And each pizza costs Sally $4 to make. How many pizzas does Sally need to sell to break even? Okay, to break even. How many pizzas does Sally need to sell to break even? Well, to break even means that she's going to make money on her pizzas. She spent $600 on the equipment, right? So in other words, the money that she makes, when is that going to equal the money that she spent, right? And she spent $600 to get started, and she spends money every time she makes a pizza. Okay? So we're going to have to assume here that the $12 each for selling pizzas is all profit. We'd have to know what the profit is on each pizza that she sells, right? But anyway, that'll shake out in the equation. So we need to come up with a situation, an equation that models this. So how many pizzas does Sally need? We need to define a variable first, and we can call it P. Right? P is the number of pizzas. That's what we don't know. Okay? Now, what are her costs? She spent $600. And her costs, we add to her cost every time she makes a pizza. And we're adding $4 each pizza. And there's that word each, which means you should be multiplying that $4 by something. Well, the $4 we're going to multiply by is the number of pizzas, which we don't know, which is P. Okay? We want to know when that equals the money that she makes for selling pizza, which is $12 per pizza. $12 each. There's that word each again. So we need to take 12 and multiply it by the number of pizzas, or P. So that's the equation you should come up with. Okay? We got an equation where we have a variable on either side. And so we want to start to solve this guy. We want to move this 4P over. So I want to add out to 0 on the left-hand side by subtracting 4P. And so we get 8P, and then we're going to divide by 8. And so P is, 75 is what we get there. Okay? So she has to sell 75 pizzas to break even. All right? Hopefully you got that. All right. Let's go take a look at these two algebraic proofs, and we'll be all done. And they're a lot like the first ones. We're going to add a couple of things here. Okay? We're going to add a couple of reasons in here. All right? So we're going to start with 6x minus 2 minus 9x equals 1. And the reason we're going to give here is it was given to us. We're starting here because it was given. Okay? Now, we know that we need to combine like terms. So we do that, and we get negative 3x minus 2 equals 1. Now, why do we do that? Well, what we're doing is we're simplifying that side. So we're going to call this since we're simplifying, our reason here is just going to be simplifying. Okay? Now, we know that we need to add 2 to both sides. Right, so we get negative 3x. Oh, sorry. That's not what we want over there. We want a reason. This is the addition property. Okay, and then we get negative 3x equals 1 because we're, oh, sorry, not 1, but 3. We get that because we simplified. Okay, then we're going to divide both sides by negative 3. And this is the division property. Okay, and then so x equals -1, and that's what we get when we simplify. And so there's your algebraic proof with the added step of having to combine like terms, which we just give the reason of simplify. Okay? We got another one here for you to work. We'll get through all of this. I just like to write it out with you guys. Here's another one. Try another one. Okay, pause the video if you want and continue to work, and then come back and start it again and check your answer. But this is what we're going to come up with. So this is given to you, right? Now, next thing we're going to do is add the 4x to both sides. And we get to do that because of the addition property. It maintains equivalent equations. Okay, when we simplify, we get -18 plus 15x equals 12. Now we're going to add 18 to both sides, and that's again our addition property, which simplifies down to 15x equals 30, which is the reason we're going to give is simplify. Then we're going to divide both sides by 15, and that's due to the division property. And when we simplify, we get x equals 2. And again, an algebraic proof. I think it's just, the point here is it keeps us in a systematic approach to solving the equation, and it allows us to back our steps up with valid reasons for doing so. Okay? All right. So there you go. Your homework, which is listed in Canvas. I'll post the file with the 2 algebraic proofs in it. And then you see the numbers there. I'll write the numbers out again that is going to come from your book in Canvas as well. All right?